Okay, this is going to be part 2. Here we go.
Forming the fossil record. The flooding uprooted vegetation, moving it to regions where it accumulated and quickly became coal and oil by processes we can duplicate in the laboratory today. Experiments show that as erosion widened the rupture, its width became so great that the compressed rock beneath the subterranean chamber sprung upward, giving birth to the mid-oceanic ridge that wraps around the Earth like the seam of a baseball. The continental plates, the hydroplates, still with lubricating water beneath them.
This is based on conventional plate tectonics, by the way. They didn't mention that, but it's kind of understood. So, the hydroplate theory is his, and some other people taking it, the theory, and run with it. So, to me, it's interesting.
Slid downhill, away from the rising mid-Atlantic ridge. After the massive, slowly accelerating continental plates reached speeds of about 45 miles an hour, they ran into resistances, compressed, crushed, thickened, and buckled. The portions of the hydroplates that buckled up formed mountains. Those that buckled down formed ocean trenches. This is why these features are generally parallel to the oceanic ridges from which they slid. The hydroplates, in sliding away from the oceanic ridges, opened up very deep ocean basins into which the floodwaters retreated. Every continental basin was naturally left brimful of water, producing many post-flood lakes. Each lake that grew from rainfall or drainage from higher elevations spilled over its rim at the lowest point of the rim. That eroded a little notch in the rim, allowing even more water to flow through the notch faster, cutting the soft flood-deposited sediments even deeper.
Those were some rad hand illustrations, by the way. I don't know if you noticed that.
Process accelerated until all the lake's water dumped through a very deep slit, forming a canyon. The largest of these was the Grand Canyon. North and east of the Grand Canyon was a huge lake that I have identified and named Grand Lake. Its dumping released more water than is in all 5 of the Great Lakes combined. Grand Lake spilled over its rim, eroded its dam, 20 miles south of Page, Arizona, catastrophically forming the Grand Canyon within a few weeks.
Rapid deposition of flood deposits from tidal action means there was little time for erosion to occur between successive layers. On the long time scale envisioned by evolutionary theory, there should be considerable evidence found of erosion and infilling by successive geologic formations during the weathering expected over millions of years. The geological layers of the Grand Canyon are remarkable in showing little or no evidence of erosion between different layers. Instead, we see pancake layering, very much consistent with the rapid deposition envisioned by the flood model. Erosion did not occur until all of the layers had been deposited. But how rapidly could the canyon itself have eroded?
Freshly laid down sediments would still not have completely hardened into rock, which allows the possibility that erosion of the canyon could have taken place far more easily than if it had hardened into rock, as evolutionary theory has assumed.
That was Robert Gentry, who's the late Robert Gentry. He passed away I can't remember when, several years ago. He's mostly in this video
However, under the right conditions, water can rapidly cut its way through the hardest of rocks, such as the granites at the bottom of the Grand Canyon. Those conditions involve cavitation.
Cavitation is the rock pulverizing process associated with water flows greater than 100 feet per second. As water detaches from irregularities in the bedrock channel, vacuum bubbles are produced, inflicting hammer-like blows on the bedrock surface. Literally,
not just hammer-like blows, but also a little spark of light as you can see in that short video I referred to that I found on Wikipedia when I was researching cavitation. Sonoluminescence, I believe it is. Say that 3 times fast. Anyway, alright, sorry, I digress again.
Converting the rocks into powder.
A modern...
I'm going to pause it here because this is beyond fascinating to me, and it's still another 5 minutes or so long. So, alright, stay tuned, kids. I'll be back.